Okay, we're going to talk about power rules. And if you'll notice in our notes, the big number is called the base. And the number on the top here is called the exponent. So we're going to have three rules we're going to go over. The first rule is the power rule when the bases are the same. Okay, so if you notice in this example you have a 2. Very important that you keep the base, okay, and you add the exponents. Now there's a few forms that they have it in, okay. Expanded would just mean that you're going to write it the long way. So there's 2 2's here. There's 1, 2, 3, 4 2's there. Okay, that's the long way. The rule states that you take the 2 2's here, 4 here, you just add it up, and you would get 2. 4 plus 2 is 6. Okay. And the standard form is just taking 2 to the 6th power and making it 64. In this lesson, though, we're probably going to keep most of our problems in the exponential form because we're not going to be using calculators. All right, if you look at the next problem, we have 3 squared times 3 to the 3rd. You'll notice the base is 3, right? So we expanded it out. You could count up all the 3's, or you can use the rule. Again, the rule states that you keep the base and you add the exponents. So 3 plus 2 would be 5. 3 to the 5th power is 243. Again, I really want you to concentrate on the exponential form. All right, so again, when the bases are the same, we are going to add the exponents. All right, let's take a look at the next rule. The next rule is quotient, which just means division. Okay, it's a fancy word for division. So when we divide, now you should know, I call this like the old-fashioned way, or you could write division as a fraction, right? You've probably seen this already in 7th grade. So the rule states that you're going to keep the base, in this case it's a variable, and you're going to take the exponents and you're going to subtract them. Okay. So our first example here is that we have the base of 2. We expanded it out, so that states we have 5 2's as our numerator. We have 2 2's as our denominator. So the rule states you keep the base and you subtract the exponents. So 5 minus 2 would give us 2 to the 3rd. And you probably should know our cubes because we've studied them. That would be 8 in standard form. All right, so here's another example when you have 3 as your base. So if we expanded this, that means we have 3 3's on the top. We have 2 3's on the bottom. The rule states that we just subtract the exponents. So we're going to keep the base. 3 minus 2 is 1. And that would be in standard form. So that is our second rule. And then our third rule is going to be a power of a, oh, I'm sorry, I want to skip this rule. Let's go to the next one, all right? We're not going to talk about that rule. We don't do that anymore. And the last rule is going to be called a power of a power, okay? So when you have a power of a power, sort of like a double power, what you're going to do is you are going to take the exponents in this case and multiply them. Okay, so you're going to keep the base again, and you're going to multiply the exponents. Seem pretty simple? All right, there's a few worked out for you here. If you look at here, let's expand it a little more, right? Because there's two 2's here, but what this means is there's 3 of them. So there's a second one, a third one. So the rule states that we multiply these, so we have 2 to the 6th, which is 64. Again, we're going to concentrate on the exponential form. And the last example here is going to be 5 to the 4th. You have 2 of them. Okay. If you go back to our addition rule, you would add these, right? 4 and 4 is 8. Or, instead of expanding it, let's just use what I kind of call a shortcut. 5 times 2 is 8. Exponential form. I don't expect you to know the standard form unless we have a calculator. And again, we're not going to use calculators yet in this unit. Okay? So those are what we call the power rules. And then I'm going to go over a couple of other rules, very simple ones, in the next video. Okay? Thank you.